So the first part of this question is about wrestling with half equations and how they combine to make overall equations, but with a different twist this time, because they give you the overall equation and you've got to figure out what one of the half equations is. You can sort of do this by, guessing and see if it fits, and that's a possible approach, but it's better really to see that you can do these things systematically, because in the end that's likely to save you time. So starting point is that in the overall equation we've got 2 moles of MnO4 minus, so we're going to have to double that half equation that you're given for reduction of MnO4 minus. So we're going to get 2 MnO4 minus, that's going to become 16 H plus, and 10 electrons goes to 2 Mn2 plus and 8 H2O. And then really what we've got to do is to say, well, what do we have to add to that in order to reach this equation at the bottom? So obviously we need the H2O2, and you can see that we need 5 of them, so that's going to have 5 H2O2 there to give you that on the left. And the other thing we've got on the left is 6H plus. So notice that we've got 16H plus already from the MnO4 minus, so the only way that can drop down to 6 is if 10H plus appear on the right hand side, because then the effect is 16 minus 10 gives you those 6. So we can put plus 10H plus on the right hand side, and that looks encouraging because we've got 10 hydrogens there to balance those 10 hydrogens there. If we go to the right hand side, the Mn2 plus is taken account of. The 8 waters are all there in the final equation, so we don't have to worry about those, but we've also got these 5 O2s in the final equation, so of course they've got to come from the hydrogen peroxide, so let's put 5 O2s in there. And that now balances in terms of atoms, because we've got 10 hydrogens, 10 hydrogens, 10 oxygens, 10 oxygens, but it doesn't in terms of electrons, and of course that's because we've got to balance the 10 electrons there with 10 electrons on the right hand side there, and then that works. So that's almost the answer, except it says in its lowest terms. So you can see that we can divide that half equation through by 5 to just get H2O2 goes to O2 plus 2H plus 2E minus, and that's your answer. Okay, now the second part is a fairly standard titration calculation, but just with some extra bits and pieces thrown on the end of it. So let's see how that works. Let's just restore our overall reaction equation, because we're going to need that. So we've got 2 MnO4 minus plus 6H plus and 5 H2O2 goes to the product. So always in titration calculations, look for the substance whose concentration and volume you know, both of them, because then that can get you started. You can turn that into number of moles, and that's what we know for the KMnO4. So we can get moles of MnO4 minus is concentration times volume in dm cubed. So that kind of calculation is always what you should do to expect to do to start a titration calculation. So that's equal to 0.02, 0.0 is the concentration, volume is 23.45 cm cubed, so that's 0.02345 dm cubed, and that comes to 0.000469 moles of MnO4 minus. That's the first step. Then again, the second step in a titration calculation, you should know what's coming next, which is that now you go to the equation. Because the equation relates the moles that you've just worked out to the moles of something else, and in our case we're interested in the amount of hydrogen peroxide, so it's moles of H2O2 that we want. So you get from the equation that moles of H2O2, well, if 2 reacts with 5, it's 2.5 times the moles of MnO4 minus. So we multiply that number by 2.5 and we get 0.001725. Okay, so I'm not rounding off very much at the moment, and we're keeping lots of numbers in there and rounding off at the end. And then it says, well, okay, what do we want to know is the concentration of the undiluted hydrogen peroxide. So we've got two stages. First, we've got to work out the concentration of this stuff, which is the diluted stuff that you used for the experiment, and then scale it up to say, well, what was it before we diluted it? So we can say concentration is equal to moles over volume in dm cubed. So this is the number of moles that was used in the titration, 0.0011725. So because that's the number of moles in the titration, you need to divide it by the volume that was used in the titration, and you can see that was 25.0 cm cubed. Okay, so you've got to divide it by, well, 25 cm cubed is 0.0250 dm cubed. So it's important you get the right volume there. It's not the 250 cm cubed that it talks about initially, because you only used 25 of that in the actual experiment. So because that's moles used in the experiment, this needs to be volume used in the experiment. And that comes to 0.0469 moles per dm cubed. That's after it was diluted, but it's saying what was the undiluted concentration. So we've got to look at the way the dilution was done, and it said they took 25 of the undiluted stuff and made it up to 250. In other words, they made the volume 10 times bigger, so that means the volume, that means the concentration got 10 times smaller. So the undiluted concentration is just 10 times the value that it was when we used in the experiment. So we just multiply that number by 10, is 0.469 moles per dm cubed. Okay, and that's multiplied by 10 because it was 10 times less dilute before the volume was increased. And we've now just got to change that into grams per dm cubed. So to do that, you just got to think, well, that's the number of moles dissolved in 1 dm cubed. If I turn that into grams, it'll be in grams per dm cubed. And of course you know how to turn moles into grams, which is moles equals mass times mR. So we just multiply by the mR, and that's 0.469 times the mR of hydrogen peroxide is 34.0, comes to 15.9 grams per dm cubed. Okay, and again, I've been a bit sloppy there and not really explained my working, so you've got to say, multiply by mR to convert moles to grams is what we were doing in that step. So 15.9 grams per dm cubed is the answer. It also asks us what volume of oxygen gas would be produced. So again, we start with the moles of MnO4 minus, so let's leave that on there. And from your equation, actually we need the other half of it now, which is that 5 O2 are produced from 2 moles of MnO4 minus. So again, we've got to multiply by 2.5, because every 2 moles of MnO4 minus go to 5 moles of O2. So we get moles of O2 is 2.5 times the moles of MnO4 minus, or you could say it's the same as the moles of H2O2, which you've already calculated is 0.0011725 moles, same as it was before. And now we've just got to convert that into volume. So remember, for a gas, volume in dm cubed is equal to moles times 24.0. So you simply multiply that number by 24 and you get 0.0281 dm cubed is the answer, and it doesn't ask you to convert it into cm cubed, so that's all you need to do. And that, finally, is the end of the paper.